Well, welcome to the lab. So we've taken our water samples now and we've brought them back to our lab. So I'm back at Macquarie because we were originally wanting to do some samples on the day, but we ran out of time. So we brought the samples back here and we're going to demonstrate the technique of what you normally have done in analysing the samples. So we've got our samples here from the 4 sites, just representative values from each of those 4 locations. And we've got 2 instruments here in front of us. We've got the Hanna instrument, which is purely for ammonia. So Hanna is just a brand of water quality instrumentation. They make a whole lot of different equipment. It's quite a simple single parameter unit, this one. Very simple. Both of these work off the same technique. So that's a Hanna instrument for ammonia. And then we've got this general HARC spectrophotometer. So this is a DR1900. And this can do a whole range of parameters. So it's a bit more expensive. And obviously because it can do a whole range of capabilities. And so both of these instruments are really spectrophotometers of a sort. So they involve cuvettes, so little cells like this or this depending on the instrument, and reagents that you put in with your water sample to allow a reaction to occur. And how the instruments work is, well, this one has a specific wavelength of light that it wants to read off. With this one you program it in and you tell it what wavelength you're looking for depending on the parameter. So the wavelength of light picks up the certain reaction colours. So your reagents react with your water to give a certain colour range. And so it's then calibrated to know the depth of the colour, and then therefore it calculates the concentration of whatever the parameters are. So we've got 5 different measures we're going to use these instruments with. And so obviously the ammonia, which Kerry will demonstrate, and then we've got nitrate and phosphates being the other nutrients, and then we're also doing 2 metals. So you can do a whole range of things with this particular instrument. And so we're going to do copper and zinc being common metals that come off our urban environments into our streams. So that's the instrument. We'll go through some of the steps just to illustrate that and demonstrate how you would have normally done it if you were able to. Okay, so now I'm going to demonstrate one of the techniques that we're using the HARC spectrophotometer with, and that's for phosphates. So as I said, with this instrument, you can do a whole range of parameters, something like 200 parameters you can potentially do. Now, the beauty of this company is that you have to buy the reagents. So once you have the instrument, you can't just make up your own reagents. You've got to buy these little individually packaged reagents, so they've got some kind of continued costs involved. So I've pre-programmed the instrument here to do phosphates. I'll just demonstrate one technique. And so each method, each parameter that you're interested in has a method. And it's quite simple. It's a step-by-step guide, quite user-friendly. You program it, it tells you what to do in quite simple steps. All these are reaction-based. So as I was saying before, it's really a colour change that it's comparing and measuring off that. So with this phosphorus, so we're doing reactive phosphorus or orthophosphate. So orthophosphate is the organic kind of component of the phosphorus. So you've got inorganic and organic, and so we're measuring the form that is more bioavailable or more harmful, if you like, in the environment. You can measure total phosphates or total nitrates, but we're using the techniques and the data you'll get just for one form of either the phosphate or nitrate group. So just be aware of that. So remember, phosphates and nitrates are common contaminants in our urban streams. They wash off from our gardens, so people apply fertilizers to their gardens, and in those are nitrates and phosphates to boost growth of the plants. But not all of that gets mixed into the soil, and when there's been a rain event like we've just had up in the mountains, some of that washes into your streams. There is natural nitrates and phosphates, but generally the conditions of our soils and our streams are very low. And so why we see weeds growing along our riverbanks is because of, they like a lot of the nutrients. They're adapted to high nutrient environments. Our natives are less so, and so they proliferate along those river edges. And from those shots you saw at some of those creeks we sampled, there was definitely weeds along there. So even that alone tells us there's probably something there that's helping those weeds grow. So the water quality measures of nitrates, phosphates tells us a bit about those types of contaminants. The other thing we'll be measuring is ammonia, and Kerry will demonstrate that. That is a byproduct of some of these nitrates and phosphates, and so or nitrates in particular. So it's a breakdown product. It creates and can be toxic. So it's an interesting parameter that we use to understand the potential harm that's going on in the water from these chemicals. But I'm just going to demonstrate one technique for this exercise, and that is with the reactive phosphorus. So I've pre-programmed the instruments. As I said, you can just choose from a whole list of parameters, and I said I want to do this phosphorus measure. The first thing we do, and as I said, if we go to here, we prepare our sample. So we've got these square cuvettes, and I'll choose one of our samples. So the Kadumba Site 1, which was that unnamed tributary. And once again, there's a little line here that tells us how much to put in, and that's 10 mils. So we use our pipettes, and these are pre-rinsed, so they're clean. We always rinse our vials before we use them. And so we fill that up. One more. A little bit more. So it's important to fill exactly to that line, because we're going to be putting in a standard amount of the reagents. So these are the reagents, come in little bags, and these what are called powder pillows for most of the HARC instrumentation. So it's a little, each one of these is for one sample analysis, and so in this case they're powdered reagents. Some are liquids, some are powders. So phosphates and nitrates are both powders, and so what we do is just give it a flick, and so all the powder drops to the bottom, because you want to get all of that reagent into your vial. you get your scissors and you clip off the top of that, and then you want to open it up so you can pour it in. Now you'll notice I'm wearing gloves. The gloves is not only because of the water, we're not sure what the condition of that water is, but it's also the reagents. Some of these reagents have toxic components to them, and so it's important that we are not obviously exposing ourselves to those harmful substances. And of course, because we're in the lab, we're wearing our lab coats as is standard practice. So I'm just pouring this reagent in there. Just make sure it all goes in. That's rubbish. Then I have a stopper. And then I'm basically closing that and shaking that vigorously for 20 to 30 seconds, it says in the guide. And that is just allowing the mixing of your sample with the reagent to make sure it's well mixed. Okay, and then what we're going to do, we're going to leave it. The program says to leave it for 2 minutes. So I'm going to start a timer on the instrument. Select Start Timer. Okay, and select. That's about, and now it's, so we let that sit for 2 minutes. And so what's happening in that 2 minute period is there is possibly reaction occurring. So the chemical that is in that powder is reacting, in this case, to any orthophosphates that are there. In the meantime, while we're waiting, we create a blank or a zero. So we need to compare what is happening with your reagent sample to your blank sample. So we create another, not create, but we basically fill up the vial again with just clean water, no reagent this time, and this will be our zero. So part of the instrument's reading and needs to know what is zero, what would be something when there's no reagent there. And so that's pretty good, actually. A bit less important, isn't it? Okay. Okay, so we've got about 30 seconds left before that time. But you can, hopefully you can see, maybe you can see, I can see a colour difference already between my right hand, your left, and the other one. I'm not sure if you can pick that up, maybe on my white lab coats. So we're seeing there's already some reaction. If there was no reaction, if there was zero phosphate in there, it should be the same colour as your zero. Now, that's gone off. It's told me the 2 minutes is up. And now I can zero it. And so we open up, this is where the cell goes in here. And because it's using a light, so there's a beam of light that moves through this instrument, and same with the Hanna instrument, and that's what it's measuring the light through or off. And so what we need to do is make sure that this cell, this cuvette, is clean on all sides. Okay, and you can see I'm handling it from the top. It just gets around any smudging and things like that. So always handle your cuvettes from the top. The other thing I'll point out with the HARC instrument is that they're individually numbered, or the set is individually numbered. so this is set 452, and it's a matching pair that the cells are identical. And so if you go to another instrument, it'll have a different number on it. So you know these two cuvettes are identical to one another. So it's critical that the glass is clean and that you've got obviously the matching pair there. The other thing is that to take care of these cuvettes, because if they get scratches on them, then that interferes with the reading. And so if they're scratched, really they're no longer usable. So we need to take good care of them. Okay, so our timer's gone off. I've got the blank. I'm putting the blank in, and we put it in a certain way with the numbers facing forward. That goes in, the door goes down, and I press 0. And it's zeroing, it's basically taking a measure and calibrating the instrument to say, well, this is what it is without any reagent in it. Okay, and it comes up on the screen as 0.00 milligrams per litre. Okay, so that's our 0. And now we're going to add our actual sample. Once again, I'm just wiping that down. Always wipe, wipe, wipe. Putting it to the front, numbers to the front, push it down into the cell. Close the lid and press read. And it's processing, doing that comparison, doing those color measurements, and it comes up with a value of 0.97 milligrams per litre. So we can record that down. We'll do that for the other samples, and we'll provide you the results so you can then compare to the ANZAC water quality guidelines and also the Blue Mountains Council guidelines to see how it compares. So that's the technique. The others are the same. Sometimes the reaction time is longer or shorter depending on the reagents and what the method is. But we'll do the nitrates, the phosphates, copper and zinc. So copper and zinc, obviously, as I mentioned before, are common metals. So here's another take-home question for you. So if you can think about where copper and or zinc might be coming from, why is that entering our streams? So have a think about that, and we'll talk about that in coming classes. Okay. So this is just a second sample, just to show you the comparisons are very more slight with this sample than with the last sample. And so we've got not as much obvious phosphorus in this sample here. This is our 0 or blank, and this is the one with the reagent. So we'll see what it is. So the first one was 0.97. So I'm going to put this in now. So this is 0.14 milligrams per litre orthophosphorus. So 0.97 at site 1, 0.14 at site 2, just to give you an idea of the difference already we're getting.
Okay, so I'm going to demonstrate the method that we use to test ammonia. I've got my little vial here, a cuvee, I think it is called. It's got a line on here that says 10 mils. But before I start doing my test, what I've got to do is triple rinse my little jar so that I don't contaminate the sample with anything that's been used previously. So what I've got here is Katoomba 1. So this is our sample from Katoomba Creek. I've got a pipette. And what I'm going to do is just fill up my jar with a little bit of the sample. Put the lid on. Just give it a bit of a rinse. Pour it out and repeat this 3 times. Okay, so now I'm ready to fill up my sample. I'm going to fill it up to the 10 millimetre mark. Okay, so now we're ready to go over to the instrument. Okay, I'm now over here with the instrument that I'm using to measure ammonia. What I've done is I've turned the instrument on by pressing the on button. I need to give my little sample jar a bit of a wipe just to get any of the any water or any of the sample that's on the outside, so just make sure it's clean and dry. Got the lid on nice and tight. And what I'm first going to do is zero my instrument. There's a little notch on my jar, so I'm just going to make sure that the notch is aligned. There it is, it's in nice and tight like that, and press the 0 button. So it only takes a few seconds just to zero the instrument. It's like a calibration process where I'm calibrating the instrument. Okay, I've got 0 on the screen, so I'm good to now start adding my reagents to my sample. Okay, it's a pretty simple process. All I'm doing is going to add 2 different reagents. The first reagent is, well, they kind of all look the same, but this one, it's labelled B. And what I need to do is add 4 drops of B. 1, 2, 3, 4. I then put my lid on, give it a bit of a shake. And I'm now going to add 4 drops of reagent A. One, 2, 3, 4. Pick that. And then press read. So it's a timed read. It takes about 3 minutes and 30 seconds. So it's just going to time the reaction that's happening as a result of those reagents in the sample. So in those, once the timer is up, it will give me a reading on what my ammonia levels are in my sample here. So this is Katoomba Creek, so I'll get the ammonia reading for Katoomba Creek. Okay, my instrument's just finished its countdown, and it's now got a result on the screen. And so my result for ammonia is 0.22 milligrams per litre. So what you'll need to do with these sort of data is actually cross-check against things like ANZAC guidelines and also the trigger values for the Blue Mountains City Council, and have a look at the previous data that they've collected from Katoomba Creek to see whether this sort of value of 0.22 milligrams per litre is sort of within the range or higher or lower than previous recordings from that site.